Okay, for my next review, I'm looking at a couple of labs from North Dakota University, and these two labs kind of go hand in hand. The first is an introduction to how pH works, and then the second where your students will look at the pH of several different salsas. I like that this is applicable. I like that it's pretty easy to follow, and it walks them through things. So we'll go through it a little bit here, and we'll come back and talk about it later.
A substance's pH describes how acidic or basic it is. The pH scale ranges from 0 to 14, with lower numbers more acidic and higher numbers more basic. Acidic substances have a pH between 0 and 7. Those with pH above 4.6 but below 7 are classified more specifically as low acid, an important category in food science.
So I must admit, the first time I got to this, I got a little frustrated because I didn't know what to do from here. It wasn't a little clear, and I think this is something that happens in virtual labs sometimes. It's like, what am I supposed to do? There's no next button, no whatever. And I realized that you have to click on all of these little glowing orbs, and if you do that, then it moves on. So again, a good lab, but sometimes I get a little stuck, and I'm sure that might happen to my students as well.
A basic or alkaline substance has a pH between 7 and 14. Here are pH levels for some basic substances. You will try the most basic form of testing, pH indicator paper. Indicator paper changes color depending on the pH of what you dip it in. Dip a strip of paper in each beaker and then take it out.
So I like this. I mean, it's working through the same stuff we might do in a normal lab. And here we go. We match them up. And it kind of clicks into place when you've done a good job, which certainly helps. And here we are. We sort of explain the pH.
Scientists care a lot about pH because a food's acidity level influences what we need to do to store it safely.
This is where I think this lab actually has its strength, as it gets to the applicability of the idea of testing and managing pH.
Consider this jar of salsa from the Spicy Salsa Company. Canned and jarred goods are vulnerable to an organism called Clostridium botulinum, or CBOT for short. CBOT is common in the environment and is usually harmless. But when CBOT grows under anaerobic conditions, it produces deadly toxins. When the neurotoxins produced by CBOT are ingested by humans, they can paralyze or kill. This is called botulism.
Again, I think this is a really good demonstration of the problem. And what I'm going to do is I'm going to turn off the audio for a bit and kind of work my way through it here. So here it points out that you want a pH below 4.6 in order to be safe from botulism. And then I think it asks you where you want that to be. And then it gets you to this idea of, okay, so you're producing salsa. And how do you make sure that your salsa has a pH below that level? And again, below that level of 4.6 will make them less susceptible to botulism. And so it says, do you remember it? Yeah, you find 4.6, you get to move on. And then it says, and I think this is where it gets neat, is it says, all right, so here are the ingredients of salsa. And so you drop them onto their different spots. And once you do that, you realize that the pH of normal salsa is probably going to be above that 4.6, in which case it'll be at risk of getting botulism. So that's the end of this lab. It really does a good job of sort of presenting the problem and explaining how the pH meter works. The second part of the second lab, which I think goes really well hand in hand with it.
As a food scientist, your job is to keep food safe from spoilage organisms and pathogens. Your training has taught you to control microorganisms in food by controlling the food's pH.
The second lab allows you to actually adjust the pH and look at how a scientist might go about figuring out the right pH in order to manipulate the salsa so that it doesn't get botulism. And so again, with the audio off here, it kind of goes through some of the same concepts. Again, there's just this challenge of finding the right thing to click on sometimes. But other than that, I think it's good. Here it points out our goal. Here it says if we cook it, that helps, but it doesn't solve our problem. And what we really need to do is lower the pH. And here it goes through. We can pick either of these different things that we want to work with. We're going to go ahead and work with lemon juice. And we'll say next. And it allows us to pour lemon juice into several different containers. And we actually create two experimental conditions here with two different amounts of lemon juice. And then and then we homogenize our solutions by pouring them into a blender. Maybe this is a little bit excessive. I'll jump ahead here and we'll get to the point where we have all of these done. Okay, so when we're done, we have 2 samples of using a large volume of acid, 2 where we use a little bit less, and then of course a control. And so from here we can go ahead and start testing the pHs of these different salsas. We actually did 2 samples in each condition, which I think is good stuff, and it demonstrates good science. Here it talks to us about how to use and calibrate a pH meter. We got to rinse the pH meter off, and then it goes through and explains how we do the different parts of it. Once we've got the pH meter ready, we can use it to measure the pH of the different solutions and rinse it off each time. And then we do it again, and then we rinse it off again, and it measures the pH. I like that it doesn't show exactly the pH we would want, and it has us recording our data. This goes on, and again, I'm going to jump ahead and then show you what the data actually shows and how the lab processes it. So here they point out that in a real lab, you'd actually go through the process of sampling each sample a couple of times and then calculating an average. It doesn't do the best job of explaining what it's doing here, but I think the steps are good and they could be drawn out in a worksheet or some kind of supplemental activity. But it explains the value of, it at least demonstrates the value of multiple samples. And then as we go through here.
Now you have taken 2 independent pH measurements, each of which is the average of 2 pH readings for each of your new salsa samples. The 1 liter salsa plus 40 milliliters acid, the 1 liter salsa plus 80 milliliters acid, and the control.
So again, I think this is great. And then it asks you as a scientist, which one would you choose? I think for me, I'd choose the most acidic just to keep things safe, but you could make an argument in different ways. So as we go through it, which one should we choose? I'm going to take the A2, the most acidic, and they seem to like my decision. I'm curious what they would have said if I said something else, but hey, I guess I got it right on the first try. And it points out that it might be helpful to run more trials and more tests. Again, I think this is good. It says your process is never over, and in the end, you can go back and retest the whole thing. These 2 labs together are great. They have they teach some fundamental ideas about what pH is, and they're very, very clean as standalone. You test the pH, it runs through and runs a whole experiment. There's some good scientific processes there. I like these 2 together. These are the kind of labs you could actually ask your kids to do at home and alone. They'd get through and maybe have them do some kind of a worksheet, and then they could give you good results. Again, my one concern is there's some areas where I feel like you might get stuck and not know where to click. But for the most part, the lab is well run, and I think it would be educational value.